Hi, in this lesson I'm going to be showing you how you can identify values of the gradient and y-intercept for non-standard equations of straight lines. I'm going to start really straightforward. So we all know, hopefully by this point, that y equals mx plus c is the standard way of writing the equation of a straight line. And so the m is always standing for the gradient. The value of the m is the gradient, and the c value is the y-axis intercept. Okay, so with that in mind, we should be able to pick out the values of the gradient and the y-axis intercept in this. So this equation of straight line is y equals 4x plus 6, okay, with gradient 4 and y-axis intercept 6, okay. Bit less obvious to see on this one, but there's nothing wrong with swapping these things around. You can see the x term is actually the second term mentioned here. If we just swap them around into become minus 2x plus 6, okay, you can see now it's in that form mx first plus c. So here the gradient is negative 2 and the y-axis intercept is 6. Okay. All right, and then we can get ones like this. So all we need to do here is notice it's not quite in this form yet, okay, because we've got 2y at the beginning. So all we have to do actually is just divide by 2 on both sides of the equation. So a lot of the skills that we use when we solve equations come in here. So if we do 2y and divide it by 2, we get 1y. And then we divide both of these terms by 2. So 10x divided by 2 is 5x. And minus 8 divided by 2 is minus 4. Okay, and then from here, I can, if I was asked, the gradient is equal to 5, and the y-axis intercept is at negative 4. Okay. All right, next. Okay, same sort of idea. Now I just haven't got the y on its own on this side. It's usually y equals mx plus c. So whatever's not, on the left, whatever's on the left-hand side that shouldn't be, I'm going to move to the other side. In this case, it's x. So I'm going to subtract x from both sides of the equation to be balanced. And so what I get is y equals negative x plus 4. And from here, if I was asked what the gradient value is, it's negative 1. That's the number in front of the x term. And the y-axis intercept here is 4. Okay. Here, okay, same sort of idea. I've got two things on the left-hand side. To be honest, one of my y term's negative. I don't want to have a negative y term, so I'm actually going to move the y term straight away to get it to be positive on the other side, and then I'll deal with that in a second. So if I do that, I get, at this point, I get x on its own, and the 3y is moving over here, so I get 3y equals 5. Oh, sorry, 3y plus 5. Okay, and then I just need to get everything apart from the y term to the other side. I'm probably going to take away 5 at this point. I want to get the positive y term on its own, and then I'll think about moving things after that. So we get x subtract 5 equals 3y. And then it's a bit like this example here. All I have to do now is just divide everything by 3. Okay, what I might do first of all is just write it the other way around. So 3y equals x minus 5. And then the last job is to, I've run out of room, sorry, divide by 3 on both sides. So I get 3y divided by 3 is 1y. And then x divided by 3 is a third x. And then 5 divided by 3, or minus 5 divided by 3 is minus 5 thirds. Okay, so not so easy, that one. So here I've got the gradient value, if I was asked, to be 1/3, and the y-intercept is at minus 5/3. Okay. Right. Now then, the next sorts of questions, I'm just going to go through quite quickly what we might do here. So